Hey y'all, it's your main math teacher, Mr. Boyd, and I'm back at it again today. And today we're going to extend our previous learning to figure out how to find the area of any triangle. Remember in our last lesson, we learned about how to find the area of triangles where we know the base and the height. So for example, if we have a triangle like this one with a base of 4 and a height of 3, we learned base times height, divide that by 2. So in this case, 4 times 3 divide by 2, and we get 6 when we do that. Okay, sometimes we're going to run into triangles for which that doesn't necessarily work. So for example, over here on the right side of the screen, we see the base down here at the bottom, but A and C are not the height because they're not perpendicular to the base, or as some of us said in class, they're slanted. Okay, so we're going to learn how to get past that today. Rather than dealing with this general triangle as our first example, I think I want to start with a numeric example, and I think this is going to be easier for you to understand. So let's build off our prior understanding. Remember, we said that the area of a triangle is going to be base times height divided by 2. So let's try to fill in that information. Let's see what happens. Looking at this triangle, I hope you can see that the base is 60. I'm going to fill in 60. For the height, I don't know what the height is, but I know it's not 36, and it's going to be over 2. So when we try to use our understanding to find the area, we run into a little bit of a roadblock. We need to know the height. So y'all, if we don't know the height, and that's what would be needed to find the area, guess what we're going to do? We're going to have to find the height. So what I'm going to do is I'm going to draw in the height right here. Okay, and there it is. So I've got this new triangle, and I'm going to focus on the right side of the page because it has more information. Do my best little drawing here. Okay, and I've got 27 in there, 27 degrees. And the base is, I don't know the base anymore. I know that the whole base of the original triangle is 60, but keep in mind, I cut it in half. I'm only dealing with that, so I actually have lost that information. However, the hypotenuse of this one is still 36. And what I'm after is the height. I really want to know the height. Now, with what we see here, we need to remember how to solve that. And well, what is that? What techniques have we learned that deal with a right triangle where we know one side length, one angle measurement, and we want to find the missing side length? Well, folks, that's a SOHCAHTOA calculation. So this might be a really good spot to pause the video and try to do the next step on your own. Try to find x. That's a really good refresher from our previous unit. So here I go. I'm going to work on it as well. Okay, and so what I get when I do that, I see that this is sine. So I get sine of 27 degrees equals the opposite side, x, over 36. I'm going to multiply both sides by 36. And then it's calculator time. So 36 sine 27. And I get 16.3 when I do that. So x equals 16.3. I'm going to label this picture up here so I understand it. 16.3. And then from that, I'm able to see that I now know the height. So this is also 16.3. And now, to find the total area, it's calculator time. So 60 times 16.3, we're going to divide that by 2, and I get 489 when I do that. I'm going to double check it and make sure. So 60 times 16.3 divided by 2, and sure enough, 489. And let's get our units. That's going to be millimeters. Remember this from the last lesson? Squared, because it's area. Now with that understanding, let's return back to where we started. That was a little bit of a process. We had to think about where the height was. We then had to figure out how to find the height. We had to use SOHCAHTOA, which added more steps to our process. And then we had to plug it back into the area formula. What we're after now is I want an easier, quicker way. So we've done a specific process. Now I want to generalize that so it'll work for, as you can see here, any triangle. So what we're going to do, we're going to run through the exact same process on this triangle and see if there's access to a shortcut. So remembering, we want base times height divided by 2. Where's the base at on this one? The base is b. Hey, that's nice, same letter. And then the height is, I'll have to draw it in. Okay, make sure it's a right angle. And we're going to divide by 2. So now I'm going to set about some side work to figure out how to find this angle. And for the purpose of this matching our textbook, I'm going to use the triangle on the left, and I'm going to use C. So folks, here's what it's going to look like. I've got this angle as C, and I've got A as the hypotenuse, and B just got chopped in half, so I'm going to put a little X through that to make sure I'm not going to use it because it got chopped in half. Or not in half, it got chopped into 2 pieces, excuse me. It may be in half, it may be not, I don't really know yet. Okay, so here's what I'm going to do. I want the height, and so I'm going to set up a sine equation for this, just like we did a moment ago. So sine of angle C, I don't know how many degrees, so I'm going to use C, equals the opposite side, which is H, over the hypotenuse, which is A, and then I'm going to multiply both sides by A. And so what I get is that the height of the triangle is A sine C. Okay, and that overwhelms people a little bit, so I'm going to reformat it a little bit. So the area of any triangle is AB sine C divided by 2, where A and B are sides, and they follow a side angle side relationship with the angle there. Okay, and that will work every time. So I want to go back now to an example so you can see how this works. Okay, and let's go to this one. So here's all it is. And y'all, here's the amazing thing. Once you get good at this, you don't even have to show work. There's no steps to it. You literally just learn how to type in the numbers in the calculator. So I'm looking here, and I see I have a side angle side situation. Okay, excellent. That means this is going to apply. And so all I have to do now is I have to type in AB sine C divided by 2. And I don't mean type in the letters, I mean figure out what those are. So what do you want to use for A? Let's use a side length. Let's use 18. And let's use 9 as the other side length because that's what was given. So 18 times 9, sine of the angle that was given, so sine 60 divided by 2. And y'all, we're just going to type that in exactly as it's written. 18 times 9 times sine of 60, divide that by 2, and I get 70.1. And it's yards squared. So I want you to notice how much quicker that is and how much easier that is than going through the whole big SOHCAHTOA process. Now, as far as things that normally confuse students, sometimes students will say things like, but wait, Mr. Boyden, look at this picture. This is the adjacent and that's the hypotenuse, so should we not have used cosine instead? We should not have used cosine instead. Folks, the reason this works is because it's based on this diagram, and in this diagram it was the opposite and the hypotenuse, and that's why we use sine initially. So this is now just a formula we plug numbers into, okay, and that's going to make it a lot easier. Now, let's go back to the first example we did and double check ourselves. That was our old method. Let's use our new method. 1/2, or let's do it as divided by 2. We're going to do AB, so 60 times 36. Sine of the angle, so sine of 27, and it's calculator time. 60 times 36 times sine of 27 divided by 2, and I get, it rounds to 490.3. Now, sometimes people get a little frustrated right here because they notice, well, wait a minute, that doesn't quite match. What the heck? Now, y'all, the reason it doesn't match is right here. Okay, so a minute ago, I rounded that answer to the nearest tenth. I actually probably should have kept more decimals on it, and we rounded it down, if you remember. So when that rounded down, it made this answer just a touch smaller. So that's another reason why this method, using the A, B, sine, C, is actually a better method, because we're not going to have these errors from rounding in the middle of our process. It's going to be a more precise version of the answer. So not only is it easier to do this process and quicker to do this process, it's actually more accurate and precise as well. Okay, let's do one more example and we'll get out of here. And I picked this one. It actually relates to something I've done before. In my backyard, there is a part of my yard that's shaped like a triangle, but it's not a right triangle. It's one of these weird sort of irregular triangles. And why do I need to know the area of it? Because I need to know how big my lot is for things like we've talked about in the past, like how much grass seed do I want to buy? How much bark do I want to buy if I'm doing landscaping? How much area is my property when I want to sell it? And I list it. And we need to make sure that's accurate so I'm not lying to the people who might want to buy my house. Okay, so let's run through this one. This one's about a park, and it's in the shape of a triangle. We have the two sides, and they're labeled on the picture. Thank you very much for that. And they form a 65-degree angle. Cool, we do have a side angle side situation. So folks, here's what I think you should do. Draw the picture. Write down the setup. Type it in your calculator. Get the answer, and then hit play. And let's see how you did, because I have a strong suspicion you could probably get this at this point. So hit pause now, because here I go. So I got 200 times 300 times sine of 65. And folks, if you've hit play, I hope you've noticed something that is not quite right. Do you see the thing that I missed? I forgot to write divide by 2, so make sure you include that. That's a really, really common mistake people make. So we're going to type that in. 200 times 300 times sine of 65. We'll divide that by 2. And I get, and they said to the nearest 100 square feet, so let's round it to the nearest 100. I get 27,200 square feet. Now, in class, when I've used this example, people say, no, that's ridiculous. Those numbers are way too big. That's 200 and that's 300 and that's 27,000? You've got to be kidding me. But you got to remember what this is saying. Remember the very first time we talked about that rectangle in the beginning of the unit, we said like literally it means how many squares fit inside of there. So if you have a park that's 200 long on this side and 300 long on that side, you can fit a lot of little 1 by 1 foot squares in there. Okay, and so that's not wrong at all. Remember, this is a two-dimensional unit. It's not linear. So sometimes these are going to be pretty big numbers. That's okay. We probably want our park to be big, so that way we could play soccer in it or baseball or play fetch with a dog or something like that. Okay, so guys, that's going to conclude this video for today. Pretty simple, couple examples, and actually fairly useful stuff. So I hope you enjoyed the video, and we'll see you next time.